So let's compute this. So material standard cost. So this company, we're making golf clubs, direct materials, 0.5 pounds for $20 per pound. Direct labor is 1 hour per unit. That's $16 per unit. So ding, ding, light bulb should go off on your head as soon as you see this. It should be direct materials. You should see 0.5 pounds. That should be as our standard per unit at $20 per pound. That's our standard cost. This is our standard quantity. Here's our standard quantity for labor. Here's our standard cost for labor. This is our total standard cost. So we could break it out into our formulas like we did. We have all the pieces we need to break out into our formulas. And this is our total standard cost here. And we know how to break it, split it out. And so now we get a new fact set. We say during it, we produced this many clubs for this much material, and it was $21 per pound for the material. And so now we can compute our quantity and price variances. So we might spit out a report. This is actually what happened. This is what we wanted to happen. And so we can just put the information here. So I'll go back and forth, right? 3,500 club heads. That's the amount of units. So standard quantity, we have 3,500 units. We need to convert it to the pounds per unit, right? Because that's what we're using here for direct materials. So we use a half pound for every unit. So we multiply 3,500 by the 0.5 to get 1,750 pounds would be our standard units that we would use. We take that standard units. So always be careful of your conversions here, right? This is where it'll trip people up. You'll get a multiple choice question and it'll assume that you didn't do this conversion. Always check your conversions into the correct units. So then we go from 1,800 and then what is our actual price, right? Actual times actual. We're figuring out actual cost on the left. That's what I do first. Our actual cost per unit was $21 per pound. So 1,800 times $21 per pound, we get our 37,800. That's how we got this information here. Then I do the next thing, the way my mind works is, well, the next easiest thing to calculate is my estimated or standard cost. So our standard cost is standard quantity times standard price. That's an easy formula, right? Actual cost is actual quantity times actual price, another easy formula. The other one's kind of a mix, so I do that last. Standard quantities times standard price. What is our standard quantity? Well, we know our standard quantity is 0.5 per unit, right? So 0.5 per unit, and then our standard price. So that our standard quantity here would be 3,500 times 0.5, or the 1,750, right? Well, here our 1,800 is our actual used. Here is our standard use, our 1,750, which comes from our quantity times our the amount of units for the quantity. And then we expect $20 per pound. So $20 per pound, we paid 21, but 20 comes from here. This is our standard cost from the direct materials, 20 per pound. That gets us our 35,000. And so we already know here the difference is 37,000 minus 37,800, and 35,000. So we know we have a total direct cost variance unfavorable of 2,800. But we have to determine how much of that is a quantity variance and how much of that is a price variance. The way to do that is determine the actual quantity times the standard price. We know the actual quantity is 1,800. We know the standard price is 20. That gets us our 36,000. This helps us to determine the price variance. 37,800 minus 36,000 is our 1,800 unfavorable. And then this helps us to determine the quantity variance. 36,000 minus our 35,000 is 1,000. And then our check here is 1,800, and the 1,000 equals 2,800 unfavorable variance. This also just makes logical sense if we think about the problem. We used more pounds than we thought we would, so it should cost more. How many more did we use? 50. And 50 times 20 is going to be our 1,000. That gets us our quantity variance because we used more. And then we also paid $1 more per unit. And so that $1 extra per unit, in addition to 1,800 units, that $1 times 1,800 units gives us our $1,800 unfavorable outcome. So that's the common sense approach as well. So they're just saying an example of how you might investigate. So you might talk to the team and say, and you talk to the person responsible, and the labor person says, hey, I'm not responsible for this. You bought cheap materials, and so we had to use more of it because it kept breaking down. But then the manager might say, you used too much material because you trained the workers poorly. So we're going to figure out better training, or your poor scheduling. So we'd have to go and investigate why these material variances existed, find the root reason, and try to fix it. Labor variances, this is the exact same formula, right? Actual cost, standard cost, actual hours times standard rate. I don't want to go into detail here. It's the exact same thing. It's just hours instead of quantity, and rate instead of price. It's the exact, I'll put up materials here, right? Materials here, labor here, actual, standard on the right, actual quantity, standard, actual hours, standard price, standard rate. It doesn't change anything. We just call this an efficiency variance rather than a quantity variance, and a rate variance rather than a price variance. It's the same thing though. Rate and price sound exactly the same. Efficiency, quantity, very similar, right? Just know the new terms, but I'm not going to spend a lot of time here because it's the exact same format as material variances. Okay, so during May, we produced 3,500 clubs heads, and we paid an average of $16.50 per club head. We have the same facts, right? We have our direct labor. We expect 1 hour per unit at $16 per unit. And we'll just do the exact same calculation. I'll go back and forth again so we all see. Really simple though, right? What's our actual? Actual is here, $16.50 per hour for the hours worked. $16.50, we say 3,400 hours. It took us 3,400 hours. This is actual. We determine that's our actual cost is $56,100. What should have our standard been? Our standard should have been here, 1 hour per unit for $16 per hour. How many units did we have? Our standard quantity is 3,500. We made 3,500 units. That's here. 1 hour per unit, that's 3,500 hours. And our standard rate was $16 an hour. That's here, $16. So it should have been 56,000. As the question here is, we're $100 off, right? Total cost variance. We spent 100 more than we expected to spend. So that $100 leads to an unfavorable cost variance. That unfavorable cost variance, we have to determine, is that a rate variance or an efficiency variance? The way we do that is by taking in the actual hours times the standard rate, right? This is our true difference. Our actual hours we pull from here, our standard rate we pull from the right, and we ultimately get that our actual hours times our standard rate is 54,400. So we find our actual costs. We spent more, but we had more efficient workers. So we spent more per hour, but we had more efficient workers. We find that by 56,100 minus the 54,400. And this makes sense because we expected it to take 3,500 hours, but we actually spent 3,400 hours. So we spent less than we expected. So obviously we had an efficiency variance, but then because we have more cost associated with it, we spent more per hour. We had a bit large rate variance that was unfavorable. Now I want us to identify the importance of us breaking out these variances. From a total cost standpoint, it doesn't look like a big variance. So a company might just say, hey, I'm not going to look into this. But it's useful to drill into it, because what we find here is our workers are doing a very good job of working very well, but it seems like we're paying them a lot more. And so what I drive to is there one employee doing a very good job that we're paying overhead to, a lot of overtime to? But what they're saying here, when we assess it, one possible explanation is different skill levels, right? If it's someone's higher skill level, they might cost more, but then they do a better job. They are a lower skill level, they spend more time, but you can pay them less. So higher skill level, pay more, but they work quicker. Lower skill level, you pay a lower rate, but they take a lot longer. And so that might be identified here. And if we just find out that we're paying someone who's more skilled, since the total cost variance comes out, we might say that's fine.